Hello friends, so in today's question, in the figure shown, if the system is in equilibrium, find the relationship in mu1 and mu2 for the case, first if the bar is just going to slide and if box is just going to slide. So this is a box which is having a mass m1, this is a rod having a mass m2 making an angle of alpha with the horizontal. Mu1 is the coefficient of friction between m1 and the ground, and mu2 is the friction coefficient between the rod as well as the ground. So first of all, it is given that the entire system is in equilibrium. Okay, you can say as the system is in equilibrium, so we can draw the various forces which are on m1 as well as m2. So let us draw for first of all for m1, for mass m1, so this is mass m1 and it is going to have m1g in the downward direction, and there will be normal which will be acting in the opposite direction. Let us suppose that is given as n, and there will be normal because of this rod, and it is acting in this direction, and angle of this is given as alpha. So we can divide this, let us say this normal is n1, so we can divide this normal into two parts. This first will be our n1 sine alpha, and this will be our n1 cos alpha. And another thing will be that this mass m1 will have the tendency to move towards left side. Okay, so it will try to move towards left because of this n1 sine alpha, and later on we will also see that m2 will have the tendency to move towards the right. And so these are the forces which will be acting on it, and like this n1 will have the tendency to move the m1 to the right side, so there will be a frictional force, let us call this fr1, which will be acting in the opposite side. Okay. From here we can write it will try to move towards left. Okay, so it will try to move in this direction. So fr1 will be acting in the opposite direction. So as the system is in equilibrium, okay, as m1 is in equilibrium, we can say that m1g plus n1 cos alpha will be equal to n. And this was in vertical direction, and in the horizontal one we are going to have n1 sine alpha will be equal to mu1 into n, okay, whereas f1 is equal to mu1 into n. So we already know value of n. We substitute it here. We get n1 sine alpha is equal to mu1 m1g plus n1 cos alpha. So we can open this bracket, we can get mu1 m1g plus mu1 n1 cos alpha. This can be further written as taking as n1 common towards left side, we get n1 sin alpha minus mu1 cos alpha is equal to mu1 m1g. Okay. And from here we can write that our n1 is equal to mu1 m1g divided by sin alpha minus mu1 cos of alpha. This was for mass m1. Similarly, we can write for mass m2. For mass m2, so this is a rod. It is making an angle of alpha, okay. And there is a normal which will be acting in this direction, that is our n1. So we can divide it in two components. One will be n1 sin alpha and another one will be n1 cos alpha, and here will be also a normal. Let us call that n2. In the downward direction we are going to have m2g. These will be various forces, okay. Now this n1 will try to force to move rod towards left side, so we are going to have a frictional force, let us call it as Fr2, acting opposite. Okay. So it will try to move towards the right side in this direction. You can see it will try to move towards right. And once again, this is m2 over. The rod is in equilibrium. So you can say as m2 is in equilibrium, so we can write various equations. As it is in equilibrium, we can say our n1 cos alpha plus n2 will be equal to, there is a downward force m2g, and second we are going to have our n1 sin alpha will be equal to mu times n2, okay, mu to n2, sorry. So from first equation we can find out that n2, let me write it here, n2 is equal to m2g minus n1 cos of alpha. We substitute the value of n2, so we get n1 sin alpha is equal to mu2, we have m2g minus n1 cos alpha. Open the bracket, we get this is mu2 m2g minus mu2 n1 cos of alpha. once again moving towards left and taking n1 as common. So we have n1 sine alpha plus mu2 cos alpha is equal to mu2 m2 g, and from here we can find out our n1 is equal to mu2 m2 g divided by sin alpha plus mu2 cos alpha. So this was our when they were in equilibrium. In the second part, now it says that in the first part it asks that your it asks for bar is going to slide. Okay. So now we come to the case 1. It states that bar is going to slide. So if bar is going to slide, so under this condition the box, okay, mass m1 is in equilibrium. Okay, it only says that bar is going to slide. Okay, so it means mass m is in equilibrium. So for the condition that the bar should be sliding, the value of, okay, so you can say for bar to just slide, for the bar to just slide, you can say our n1 sin alpha should be greater than mu2 n2. Okay, basically it means, so it is going to slide in this direction, and we have a force which is n1 sin alpha, and we have a frictional force which is Fr2, and this is equal to mu2 n2. Here the direction is normal is n2. From here we can say that it is going to slide if n1 sin alpha, that is force, it is should be either greater than or equal to the frictional force Fr2, the limit, or rather we can say limiting value or maximum value. So under this condition it is going to just slide. So we already know value of n2. Okay, we can say our n1 sin alpha is greater than or equal to mu2. We know n2 is given as m2 g minus n1 cos alpha, and once again we write it taking as n1 common. We get this as sin alpha plus mu2 cos alpha is greater than or equal to mu2 m2 g. And we can say n1 is greater than or equal to mu2 m2 g divided by sin alpha plus mu2 cos alpha. Now here we can substitute value of n1 sorry, and the value of n1 we are going to take is when for mass m is in equilibrium. Okay, so we can just put value of n1, and that is equal to mu1 m1 g. So we can say n1 is for mass m1 which is in equilibrium. We substitute value of n1, and value of n1 is our mu1 m1 g divided by sin alpha minus mu1 cos alpha is greater than or equal to mu2 m2g divided by sin alpha plus mu2 cos alpha. So from here we can directly write that our mu1 m1g is greater than or equal to mu2 m2g and sin alpha minus mu1 cos alpha divided by sin alpha plus mu2 cos alpha. So this is our relationship for between mu1 and mu2 when bar is sliding, just going to slide. Okay, this is the relation between mu1 and mu2 when bar is just going to slide. So next is mass case 2. Mass m2 is just going to slide. So under this condition the bar will be in equilibrium. Okay, so bar will be in equilibrium. Okay. So in order to just going to slide, we can say our n1 sin alpha is greater than or equal to mu1 n. So we already know value of n. We can say n1 sin alpha is greater than or equal to mu1. N is our m1g plus n1 cos of alpha. Going to open the bracket and being towards the left side, we are left with n1 sin alpha minus mu1 cos alpha is greater than or equal to mu1 m1g. And from here we can find out our n1. The n1 is equal to, n1 is greater than or equal to mu1 m1g, and this is our sin alpha minus mu1 cos alpha. And in this case the value of n1 we are going to take for bar which is in equilibrium. Okay, you can say n1 is for bar m2 which is in equilibrium. We all know its value. N1 is given as mu2 m2g divided by sin alpha plus mu2 cos alpha is greater than or equal to mu1 m1g divided by sin alpha minus mu1 cos alpha. So we can write this as mu2 m2g greater than or equal to mu1 m1g and we have it here as cross multiply. This be sine alpha plus mu2 cos alpha divided by sine alpha minus mu1 cos alpha. So you can see this is the relationship between mu1 and mu2 when mass m2 is just going to slide. Okay, so here I just want to make change. Let us call this as equation number 1 and let us call this as equation number 2. Okay, so here I have written that n1 is for the mass m1 which is in equilibrium, or here it can written that from equation 1, and from here it can be written as from equation 2. Okay, this will be more clear. This completes the question. Thank you.